Hi, my name is Maryam Saquib, and today I'm going to be talking about acids and bases. Now, what are acids? Acids are substances that ionize or break off in an aqueous solution to produce hydrogen. And what are bases? Bases are substances that produce hydroxide ions in solutions. Now, the characteristics of acids. Acids conduct electricity. Why do acids conduct electricity? Well, that's because acids are electrolytes, so their solutions in water are conductors of electricity currents. Acids react with many metals. All metals that are above hydrogen in the activity series react with acid to produce hydrogen gas. Acids generate hydrogen ions. Some electrolytes are strong and some are weak, and it depends on whether they dissociate completely or partially. Now, the strong acids are an acid that ionizes completely in a solvent, and the weak acid is an acid that releases few hydrogen ions and they ionize partially. Now going on to bases. Bases are another class of electrolytes. Unlike acids, which are usually liquid or gases, bases are solid. Base solutions are usually slippery to the touch, but touching bases is an unsafe way to identify them. The slippery feel comes about because bases react with the oils and greases, make bases useful in cleaning agents. Bases generate hydroxide ions. Hydroxide ions can either be strong bases or weak bases, just like the acids. Strong bases are bases that ionize completely in a solvent, while weak bases are a base that releases few hydroxide ions and partially ionize in a solvent. Now moving on to the Bronsted-Lowry classification. Bronsted-Lowry theory is an acid-base reaction theory which was proposed independently by Johannes Nicholas Bronsted and Thomas Martin Lowry in 1923. Now, what are Bronsted-Lowry acids? Bronsted-Lowry acids are a substance that donate a proton to another substance. An example would be, so I'm using the example from the book. The Bronsted-Lowry acid in this case would be HCl, and it will donate hydrogen to H2O and it will become H3O plus Cl minus. Now let's talk about Bronsted-Lowry base. Now what is that? A Bronsted-Lowry base is a substance that accepts a proton. And I'm going to set an example on the board right now. Now this example is again from the book. In this equation, NH, which is ammonia, is the Bronsted-Lowry base because it accepts the hydrogen from the H2O. So it's a Bronsted. Now let's talk about conjugate acids and bases. So amphotic describes a substance such as water that has the properties of an acid and the properties of a base. So the example from the book would be that the hydrogen carbonate ion HCO-3 is amphoteric in aqueous solution. For example, it can act as an acid by donating a proton to an ammonia molecule. Alternatively, the hydrogen carbonate ion can act as a base when, for example, it accepts a proton from the hydrogen ion. So it can either donate or accept. So that means it can act as both an acid or a proton depending on whether it accepts or donates. Now let's talk about the pH levels. So there is one side that is acidic and one side that is basic, and the middle is neutral, which is green, and the number is 7. And mostly natural things are neutral, like for example water. The pH level of water should be 7. Now neutralization. What is a neutralization reaction? A neutralization reaction is basically a reaction that happens when you it's basically the reaction of ions that are characterized by acids and the ions that are characterized by bases to form water molecules and salt. So here's an example. Basically, you take a strong acid like nitric acid for example, and a strong base, which is like hydroxide, sodium hydroxide. You mix it together. It will give you a neutralized reaction, and it produces sodium nitrate, which has a neutral pH of 7. So thank you for watching. I know I have horrible speech skills, but I tried, and this is all that we covered in chapter 15, and I tried to put everything into this video.